Good morning students, myself Dr. Vishnu CC, Assistant Professor, Department of Chemistry, JSS, Arts, Science and Commerce Degree College, Gokak. This college is affiliated to Ranichanam University, Belagavi. In previous video, we studied types of molecularity of a reaction. There are three types of molecularity of a reaction. First one is unimolecularity of a reaction, bimolecularity of a reaction and trimolecularity of a reaction. In that, we studied definition of unimolecularity of a reaction with example, definition of bimolecularity of a reaction with example, and trimolecularity of a reaction with example. These are the three types of molecularity of a reaction. With this, we also studied definition of rate laws and how to write the rate expression for rate laws also, and definition of order of a reaction and how to write the order of such a reaction is m plus n. By this we also studied definition of first order reaction with example, definition of a second order reaction with example, definition of third order reaction with example, and definition of a zero order reaction with example. Lastly, we studied three unit of order of reaction, that is zero order reaction, first order reaction and second order reaction. Today we will discuss difference between order of a reaction and molecularity of a reaction. In order of a reaction, it is the sum of the powers of concentrations in the rate law. But in molecularity of a reaction, it is the total number of reacting molecules which take part in a chemical reaction. In order of a reaction, it is experimentally determined value, but in molecularity of a reaction, it is theoretical concept. In order of a reaction, it can have fractional value, but in molecularity of a reaction, it is always a whole number. In order of a reaction, it can assume zero value, but in molecularity of a reaction, it cannot have a zero value. In order of a reaction can change with conditions such as temperature, pressure and concentration, but in molecularity of a reaction is unchanged in chemical reaction. These are the difference between order of a reaction and molecularity of a reaction. Next is derivation of rate constant of a second order reaction when the concentration of two reactant are equal, that is A equals B. Consider a general second order reaction, that is 2A gives product. At time t equals 0, the initial concentration of the reactant is small a, the product is 0. After time t, there is x moles of product have been formed. The remaining concentration of initial concentration minus product, that will give the remaining concentration of the reactant, that is A minus x. Then how will write the rate expression for this reaction? The rate of reaction is given by dx by dt is directly proportional to the concentration of A square. Remove the proportionality and put rate K2 as a rate constant. Then what happens? The equation dx by dt equals K2 into A minus x whole square. This is the equation number 1. Rearrange the terms in the above equation 1. Then what happens? The equation dx divided by A minus x whole square equals K2 dt. Integrate on both sides above equation. What happens? The equation integration of dx divided by A minus x whole square equals integration of K2 dt. By integration of A minus x whole square, we will get 1 divided by A minus x. By integration of dt, we will get t, then what happens the equation k to t plus c. This is the equation number 2. C is the integration constant. When t is equal to 0 and x is equal to 0, what happens the equation? 1 divided by a minus 0 equals k2 into 0 plus c. Then what happens the equation? C is equal to 1 by a. Substitute the value of c in equation number 2. What happens the equation? 1 divided by a minus x equals k to t plus 1 by a. 1 by a put in left hand side. What happens the equation? Minus 1 divided by a minus x minus 1 by a equals k to t. Cross multiply the 1 divided by a minus x minus 1 by a. What happens the equation? A minus into a minus x divided by a into a minus x equals k to t. Here next what happens? Remove the bracket, minus into minus plus. What happens the equation? A minus a plus x divided by a into a minus x equals k to t. Here plus a minus a is cancelled. Then what happens the equation? X divided by a into a minus x equals k to t. Rearrange this equation, then the equation is k2 is equal to 1 by t into x divided by a into a minus x. This is the integrated rate equation for a second order reaction. By plotting the graph of x divided by a into a minus x versus time t, there is a straight line. After that there is a slope will comes. Slope is equal to AB by BC. Slope is equal to K divided by 2.303. K put outside. K is equal to 2.303 into slope. By this equation, by this formula, we calculate the rate constant for second order reaction. Thank you.